In this tutorial, we will be talking about collisions in Bullet, specifically about animated versus deforming geometry, what are their differences, when to use each one, and how they might affect the behavior of constraints. As always, I have to make some assumptions. This is not a tutorial about Bullet or how to create destructions. This is neither a tutorial about constraints. I assume that you have some familiarity with Bullet, that you have used some constraints before, and that you understand what attributes are. If before you have tried to use a character as a collider, you might be familiar with these two options here. If you go to initial object type, you will have a bunch of options, but for characters and in general any sort of animated collider, these are the main options: create animated static object and create deforming static objects. These are the two ones we will be talking along these videos. So what is their main difference and when should you use each one? And in order to show you what's their difference, I have this very simple scene that I'm gonna use to explain. So before going into detail, let me show you what I have. So I have one grid. I'm randomizing the normals. I have one sphere in the center and a mountain just to give it some details. And then I'm using a copy to points. Then I'm using an RBD configure and I'm setting the name to spheres. And I'm not doing anything else. In these videos, I'm gonna be using this point wrangle, so everything is more clear for you. So I have this wrangle called bullet attributes, and I'm setting only these three attributes. But there are plenty more than this. Actually, if you want to have a look at what attributes are available, you can create a dot network, create an RBD packed object, and then look for its help. And as you can see, there are tons of attributes. And most of them, you can override them as attributes from subs, which we will be doing in this tutorial. So with that said, let's go back to the actual scene. So all this part here on the left is the actual dynamic geometry, and this in the right, it's the collider. So let me show you very quickly the collider. I'm creating one box, I'm transforming the box, so it has some rotation and some translation. Then I'm using an RBD configure to change the name, and then I'm using this point wrangle to set the attributes for bullet. So you can see that this one, it's set to active equal 1, animated 0 and deforming 0. While this one, it's set to active 0, animated 0 and deforming 1. I'll explain later what this means. Then I'm merging everything together, and I have a top simulation where I'm bringing everything inside this RBD packed object. I'm setting the override attributes to active, animated and deforming. This is basically the default parameters. And I have a rigid body solver where I didn't change anything. I have a multiple solver, gravity without any change, and a ground plane. If I press play, what you will see is that the pieces are colliding with the box. Now, Bullet looks for these attributes in order to know what to do with the geometry. Because in here we have the bullet attribute set to active 1 and the rest of the attributes are set to 0. Bullet knows that these pieces of geometry should be dynamic and they should interact with anything that pushes them or moves them around. In the case of the collider, our box, active is set to 0, so Bullet knows that this is not a dynamic object that should fall. Animated is set to 0, so it knows that it doesn't look for the transform, which I'm gonna talk more about later. But deforming is set to 1. So Bullet knows that this geometry should be changing shape, and what it's going to do, it's revealed or recreate the shape or the volume of the box. So let me show you very quickly what this is. If I toggle off display geometry, and then I go to Bullet data, and then I show guide geometry, what you can see is the collision representation of each one of these pieces here. If I press play, you can see that the geometry is changing shape. Now, bear in mind that if you have show guide geometry active, the display is gonna be quite slow. But what's happening is that Bullet, it's rebuilding this volume representation of the geometry in every substep. Now let me show you the other option. Here on the right we have exactly the same box, but rather than packing it and using the RBD configure after the transform, I'm doing the RBD configure before the transform, and then I'm setting bullet attributes to active 0, animated 1, and deforming 0. When animated it's set to 1 and deforming it's set to 0. Bullet is gonna do something fairly similar to what we had before with the deforming geometry. You can see it's also colliding and it's interacting. The main difference now is that rather than rebuilding the volume representation of this box in every frame, what it's doing is that it creates the volume representation once and then it uses the transform of this geometry to move around the volume representation. So where is this getting that transform? Okay, so let me show you quickly. If I go to my box in the left and then I go to primitives in the geometry spreadsheet, then I go to intrinsics and I have a look at the transform. You can see that the transform, it's always the identity matrix, even though the box is changing. And this is happening because the RBD configure is happening after the transform. Let's have a look at the opposite case, where we have the transform after the packing. In this case, you can see that the intrinsic transform starts as the identity, but as the transform starts changing the position of the box, that identity matrix starts changing too. And this is the information that Bullet is using to drive the change or the transformation of the volume representation of this shape. So you might be thinking, what's the advantage of using this or this? In a simple case like this, there's not a big difference, although I'm gonna do a flipbook and you will see that it actually looks different. So I just went ahead and made two very quick flipbooks. This one here is the one where the box is set as deforming geometry. And now let's have a look at the one where the box is set to animated static object. As you can see, there's a big difference in how they behave. So this is good to keep in mind. The results you're going to get